G'day, my name's Steve and you're watching Reevesy Workshops. Today I'm going to continue on with my linear measurement series. We're going to talk about how to read a micrometer and a vernier, as well as look at some of the other instruments you use for measuring, particularly when using the lathe and the milling machine. So this is linear measurement part 3. I'm going to begin by showing you how to read a micrometer, as this is probably something you're familiar with already. It's certainly one of the most used tools in the workshop. Here we have an imperial micrometer that goes from 0 to 1 inch. Here we have its metric equivalent, 0 to 25 mil. These are used for measuring outside diameters. But in fact there are other types of micrometers. This is a depth micrometer, so say you've drilled or bored a hole, you want to know how deep it is to the bottom. This will measure that, and you can see the finger that comes out for it. This one here is used for measuring the inside diameter of a hole. And over here I've just shown you two more examples of micrometers of bigger sizes. This one's a 1 to 2 inch, and this one's a 2 to 3 inch, and they get even bigger and bigger and bigger as you go along. Over here we have another form of micrometer that measures the inside diameter of something. As you can see, it's designed for large holes, and then to the right of it here we have a telescopic gauge, and I'll show you how to use those as well. Next in line is our verniers, and what I'm showing you here is a progression from the earliest type to the latest type. So this type here is our pure analogue, and this is the one I'm going to show you how to read. From there they went to a dial type, as you can see here, nice and easy to read. That's a metric one. And then its modern equivalent is the digital type, which can convert from metric to imperial anytime you need to. You also get different variations. Here's a digital vertical mic, and this is used for marking out. Now marking out's another subject that we'll cover in the future. Now unfortunately my little camera here is not very good at picking up fine detail, so what I've decided to do is use the whiteboard to enlarge the scale to give you an idea on how to read a micrometer. And I'm going to start with the imperial micrometer first. So the first thing is, how do we actually operate a micrometer? So here it is, and I've got a bar in it. So what you do is you wind that down until it touches, and you can hear the clicks from the driver at the back. And you can even lock it in place so this barrel won't move, and then you can read off the scale and it tells you what diameter that bar is. So how is the scale set up? Well, this here represents the linear scale, where the micrometer jaws, these ones here, is moving in and out. And this part here is the revolving barrel that I just showed you. So on this scale we're reading thousandths of an inch in segments, and they're segments of 25 thou. So there's 25, 50, 75, 100, 125, 150, 175, 200, and so on. On this barrel here, it is divided up into 25. So this is giving you 1/1000 or 2/1000 right up to 23, 24 and 25/1000 of an inch. So one complete turn of this barrel moves one segment. So what you do when you measure, like we've done here, and I'll see if the camera can pick it up for you without smudging it, but you'll see, you can see the 400, and then just past the 400 is another segment, and then it has 12 written on the barrel. So what that's saying is the diameter of this bar is 400 thou plus the first segment of 25, and then we see a 12 on here. So what we do is we add the 12 to the 25, which gives us 37. So it ends up being a measurement of 437 thou. So I've just measured the bar now, and it's reading 437. Well, how did I work that out? Well, first of all, we can see that it's past 400. So it's 400 and something. I'll just take that out. We'll go back to there. Now that's 400. Turning the barrel, there's 425. So we know it's bigger than that. So if I just go, say, 20 more, that would be 400 plus the 25 plus 20, giving 445. So that bar, as you can see, slips in there, so I'll just very carefully wind it in. Just make sure it's reaching that maximum diameter, which it is. I'll lock it. Now you see the 12. So we've gone past the 400. We've gone past the first segment 25, and actually we've got 13 there. So we've got 13. So it's 13 plus 25 plus the 400. So it's 437. Okay, so let's have a look at how a metric micrometer works. By the way, I reckon that spelling is right. People would disagree with me and put the R and the E round the other way round. But that to me is how meter is spelt. It's the same principle with this as it was with the other one. So what we have is 1 millimeter scales here. So that's 1, 2, 3, 4, 5. And you see I've only gone as far as 10. But for a 0 to 25 millimeter micrometer, that would go to 25. Each one of these 1 millimeter segments is divided in half. So this is half a millimeter, or 0.5 of a millimeter, 1 millimeter, 1.5, and so forth. The barrel, once again, turns this way, moving this way, and it has a scale dividing the 1 millimeter up into 10 segments. So we're going 1, 2, 3, 4, 5. If we go all the way around the barrel, come around the other side, you see 45, 46, 47, 48, 49, 50. So that's representing half a mil. One turn of the barrel is half a mil. So it'll move from there to there. And once again, like before, we're going to add numbers up. So I'll just grab my piece of bar, and it's the same principle as you saw before, whereby we very carefully wind the barrel in using the ratchet drive on the end until we can get it to accurately sit on that bar. In fact, it's not. I'm going to back it off a little bit. Try again. I think we've got it that time. There we go. So I've turned it till the ratchet stops, or I should say the barrel stops turning and the ratchet clicks. We can lock it in place. So what is that reading? Well, what we can see the 10 there, but we can actually see one more segment, so that means it's 11 point something. We can't see the half segment there. If I was to wind that on, you'll see it appears, but in fact it's less than that. That's actually where it is. So we know it's 11 point something. So we can see the 0.1 there, and it's actually 3 more units above. So that makes it 0.1 plus 3, which is 0.13. So this is 11.13. Okay, so let's move on to the Vernier Calliper, or as one of my friends likes to nickname it, the Vernier. And that's a bit of a pun, because a Vernier Calliper can't measure to the same accuracy that a micrometer does, but it is a useful tool to use, particularly in larger diameters that are beyond what your micrometer can do. You just got to be wary that it may not be as accurate as a micrometer is, and you have to make allowance for that when you're machining. So we've shown you the digital vernier, and I've shown you the dial vernier, but some of you might have this type here, which is the original type of vernier, the linear one. So what you see here, I've reproduced on the board here to make it easier for you to see, and you'll see this particular Vernier caliper has imperial units on the top of it, metric units on the bottom. So how do we use a vernier? Well, a vernier slides. You've probably heard the term slide rule, which is used in maths to work out measurements of things, and draftsmen used them when they were designing things. And this works on a similar principle to that. So it will slide along, and you read the units like the micrometer from left to right. So what we can do is we can go along and measure that diameter again, which is there. I'll lock it in place, take that bar out. Now this one here is a fine scale. You can see it moves. So the idea is, if you're trying to get more sensitivity out of your instrument, you would lock that one down, have this one free, and by adjusting this little wheel here you can make minute movements of this and improve your accuracy. Okay, so once again we know those measurements than before, and I'll just look at the metric to start with, and we know it was 11.12. so how do we read that? So what happens is we have our main scale here, which is represented by this one. So you can see, like before, it's divided up into 1 millimeter segments. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 1 represents 10 millimeters. Continuing on, the 2 represents 2 millimeters, 20 millimeters I should say. 3 represents 30 millimeters, and so forth. To get that other decimal place, that 0.12, what you do is you use this scale here. So I'm representing that scale by this bit of paper, so we can slide it along. Now unfortunately, I have not spaced this scale out accurately, nor this, so it doesn't quite match the readings. But if you've got a vernier and you've got it in front of you while you're watching this video, you can work out what I'm about to demonstrate, and all I want to do here is demonstrate the principle of how it works. So what happens is this scale can slide along and it measures a segment of 1 millimeters. So this is 0.1 of a millimeter, 0.2 of a millimeter, 0.3, 0.4 and so forth. And these segments here go to the next decimal place. So this would be 0.01, 0.02, 0.03, 4 and so forth. So that means when we had that 1, 2, you would find that the 2 would line up with one of these lines on the scale here. So in our case we were measuring 11.12, so I'll slide that along. Now that would be exactly 11 millimeters. None of these other scales should line up in any way, and you can see, even though I haven't put the scales exactly right, we really haven't got anything lining up. This one looks like it does, but not quite. So we know that would be exactly 11 millimeters. But what actually happens is this scale will move a little bit until one of these numbers here lines up with one of these along here. So what I'll do is I'll make it move up. So you see that is in line. Now that 0 point really should be back here somewhere. This is where the error in this 2 scales is. But the idea is that that would line up, telling you the 0.02. So if you pretend for the moment that's lined up and none of the others along here has, only this one has, then we would be reading 11.12, because that's lining up. So 11.12, because that lines up. And that's how you read this sort of scale. So I've put the vernier under the Maggie lamp again, and once again you can see these are 1 millimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, giving you 10 millimeters, 20, 30, 40, and this one goes right up to 200 millimeters, or 20 centimeters. Here is our first and second decimal point scale, and you can see it goes 0.2, 0.4, 0.6, 0.8, sorry, not point, 0.0, 0.02, 0.04, 06, 08, and that becomes 0.1. So we were measuring 11.12 before. So what we can see is that's greater. In fact, this is giving me a slightly different reading than before. This is why these are not as accurate as a micrometer is, because you can see it's reading slightly less than 11 mil. So really I haven't put this on the bar properly. I haven't set it up on the bar properly. But not to worry, we'll have a look at what this is reading anyway, and just ignore the fact I haven't measured the bar properly. So we can see this 0 is at the 1, so we know it's 10 something. But what? It's not 11, because that 0 is showing less than 11. So it's point something. So what we need to do now is look at which one of these numbers along here is lining up with a scale here. And I'm just going to take it away from the Maggie lamp and have a look, because I'm not looking down on it properly and I can't quite tell exactly what it is. So I'll come back shortly. So off camera I've gone and reread that scale, and in fact I can see it's reading correctly. So why did it look like it didn't? It's because of what's called parallax error. And what I'm doing is I'm actually looking at it from an angle like this, when what you need to do is you need to look straight down. You have to look straight down onto the scale. If you don't do that, it looks like this line, or any of the other lines on this scale, has moved to where it shouldn't be. And when we're measuring accurately, you can't afford that, so you must look straight down. And when we do that, we can see the 0 has just gone past the 11. So now we're looking for which one of these lines up, and it looks like this one does. See, it lines up with that there. So we know that's 0.1. We know each of these segments is 0.02. So this must be 0.02. So we've got 0.12. So now we have 11.12. So if we go back to the whiteboard again, and this time we'll look at the imperial scale. So we're looking at the scale up the top. What happens here is, like the micrometer, it's 25 thou each segment. So that's 50 thou, 75 thou, 100 thou, 125, 150, 175, 200. So that's what the 2 represents. So that would mean that's 3, 400, 5, 600, and so forth. And then we have our secondary scale to get your thousandths. And that scale is broken up into 25 segments. Those 25 segments represents one segment here. So that gives us our thousandths of an inch from 0 to 25, and it's the same principle as before. You would measure something, so we know that's 0, we know that's 25. If we want to look for something greater than 25, then like before, we'll look for one of the segments that lines up in both scales. Now remember, this scale isn't exactly right, neither is this. I've just simply used these to demonstrate the principle of how to read the vernier. rather than actually what the figure is. So we're going to pretend that this is right, so we can see the 10 is lining up. So it would be 10 thou more than whatever that segment reads. So we know we're 25, we add the 10, so that would give us 35. So we know that we would be reading 35 thou. So going back under the Maggie lamp again, I've actually set it up as I demonstrated it to you, so you can see the 0 is just past the 25 thou mark, and I'm looking for which one of these line up, and we can see the 10 is lining up, so that makes it 25 plus 10 equaling 35 thou. And I'll just give you an example of how the mini adjuster works. So if I move that, I've locked it in place. If I move that, you can see it's sliding this jaw and its scale along. And this is how you get your minute measurement. Now, even though I showed you an error of 0.12, if I was to take the time to set this up properly, I would probably get a more accurate reading than that. But for this purpose of just showing you how to read the scales, I'm not too worried about measuring it accurately. I just want to show you what these scales are doing, why they're there, and how you add numbers up to get your reading. So hopefully that's been clear for you. Well, that's all on how to read micrometers and verniers. Unfortunately, my camera isn't designed for picking up fine detail, so having a look at the scale on the two instruments is probably a bit difficult on a small screen like a phone, but on a computer monitor you should be able to read it okay. Obviously I've got to look at another way of doing things in the future. YouTube channeling for me is certainly something very different than I've done in the past, and it's a bit of a challenge, but that's okay. We grow by learning, and by learning we can improve ourselves, so I'll just find a solution for next time. Of course, the value of having a video is you can pause it, rewind it, play it again, and do that as many times as you want until you get what I'm saying. So if you can't read the scales properly, just get your own vernier or get your own micrometer, whatever it is, and run through the steps I'm showing you. You'll get the hang of it. See you next time.